and I call this A, B, C, and here's the function. So this is f of A, B, C. So these are the input, and then this is the output. I ask you to give me the SOP. What does SOP mean?
Sum of product.
The sum of product. You have to write this Boolean function as something plus, something plus, something plus. So
And
terms,
then
for example.
product of sum is f prime, right?
Yes, very good. And the sum of product uses the ones, right? And the other one uses the zeros.
Yes.
All right, so for this example, what is the sum of product? What is the SOP expression for this Boolean function?
Okay. So the first one is a prime, b prime, c prime.
A prime, B prime, C prime. A prime, B, C prime, right?
Oh, yes, yes, yes,
Remember,
yes.
you only use the ones.
Okay, I thought you want to start from the beginning. Okay.
Well, if he asks you to find the SOP, you don't start from the beginning. You start from where you have the ones, right?
Which is the mentor?
Right, the minterm. So, and then we have this minterm A prime, B, C. Agree?
Yes. And then we have a,
Mm-hmm.
b prime, c prime.
Very good.
And then a
Mm-hmm.
prime, c.
Mm-hmm.
And then we have a, b, c prime.
Mm-hmm.
Then a, b, c. And
Perfect.
now we have to simplify, right?
Let's use the K map. So we have A and then we have BC. This is 0, 1. Do you remember the structure?
0, 0, 0, 1,
Mm-hmm.
1, 1,
Mm-hmm.
1, 0.
Perfect. Okay. Now where do we have the ones? A prime, B, C prime. So A prime,
So,
B, C prime here. Right?
uh,
Right?
yes, yes, yes.
And then A prime, B, C here.
A prime, B, C. Yes, here.
Mm-hmm. And then A, B prime, C prime. A, B prime, C prime here. Do you agree?
Yes.
A, B prime, C. A, B prime, C. And then A, B, C prime.
Which
A,
is,
B, C prime. I think here.
and then ABC is 1, 1, 1. Yes, here.
Perfect. Can you do the grouping? So you have this one, like you said, that's good. But you also have this, right?
Yes.
What is this equal to?
Uh, this is equal to 1A, and then,
That's it.
yes, that's it. That's it, because
Everything
everything,
else cancel out, yeah. And what about this square?
uh, it's gonna be B. Yes, B, only B.
This is going to be B. Because the A cancel, and then the C cancel. So
The
you
A
have,
will the A will cancel because 0 and 1 is
yes,
different than this and this. No
yes,
one matches, right?
yes, yes.
Oh,
So this Boolean function is equal to A plus B.
yes.
The circuit for this is a simple OR gate. Does it
Okay.
make sense?
A prime, A prime.
No, which term are you using? This and this?
Yes.
You see how A prime B is the common factor?
Yes, yes, yes. A prime, B.
Always have to use the common factor. Now, when
Mhm.
you put A prime B, you have C prime plus C, which is 1.
Cancelled. Mhm.
Okay, we're done with this. Now look at AB prime C prime and AB prime C. So you have AB prime as a common factor, and you have C prime plus C. So we're done with this. And then you have AB, and you have
And
C prime plus C, right?
yes, which is, it's gonna be A prime B plus A A B prime
Plus
plus AB,
plus
which is
AB. What is the common factor?
A prime plus A.
When you say, okay, just ignore this. When you say A prime plus A, what about b and b prime? What's the
B,
common factor?
there is no common factor.
There's no common factor. That means there's nothing you can do. Now you have a common factor, which is a.
Mm-hmm.
So
A
if
plus
you put
A.
a, you have b prime plus b, and here you have a prime b. B
Mm-hmm.
prime plus b is 1, right?
Yes.
So you
So
have
we have,
a prime b plus a.
and then B, A prime. No,
No,
it's gonna be. Oh, there is no common factor.
there's no
That's it.
common factor, but there is a rule. If you have x plus x prime y, it's x plus y. If you have a variable plus its complement times another variable, look at the table for x, y, and x plus y. This is 0, 0, 1, 1, 0, 1, 0, 1. Can you
Mm-hmm.
give me the truth table for x plus y?
0,
0.
1, 1, 1.
Okay, the truth table for x prime y.
Uh, X prime Y is 1, 0, the first one,
0.
and then 1,
Mm-hmm.
0,
Mm-hmm.
and then 0.
0. Now, what is x plus x prime y?
Okay. So 0 plus 1 is 1. 1 plus 0
No,
is
you're
0.
doing x plus x prime y. You're doing this plus this.
Oh, okay, okay. 0,
0.
1,
Mm-hmm.
1,
Mm-hmm.
1.
Look, x plus y is the same as x plus x prime y.
Okay.
Now, you don't have to do this. I just wanted to prove it to you.
Mm-hmm.
But now you can memorize this. This is very powerful. And so you end up with b and a. So we have a, b, c. Here's the function. Product of sum. So now we only consider the false statement, right?
A prime, B prime, C prime. A prime, B prime, C.
A prime b prime c prime plus a prime b prime c. That's it. Notice that I took the complement of the Boolean function, and in order
Now
to get
the prime will take off the other primes.
perfect, so if I put a double prime, you have to put a prime on the a prime b prime c prime plus a prime b prime c. Now, according to De Morgan law,
It's
this
gonna be ABC plus.
the plus becomes a multiplication, right?
Yes.
And the prime is for each of these terms, for a prime b prime c prime, and then a prime for a prime b prime c. Now let's simplify this. This is a multiplication, it becomes an
Plus.
addition. So you have a prime prime, it's a plus b plus c times a plus b plus c prime.
Yes, makes sense.
This is a product. You see, it's a product of sum. This is a sum, this is a sum, and these are two different ways of writing the uh, logic function corresponding to this truth table.
Mm-hmm.
How do we design this? Well, we can use an OR gate with 3 input, A, B, C, and we have another one with a NOT. You have the Boolean identities or the rules, the formulas, and you have the K-map. Memorize them. And I think we went over this. I don't know if you still have the video. If you have time, go back and watch it. Waste your time. Like x plus 0 is x, right? X
Mm-hmm.
times 1 is x. Okay, and this is proof. De Morgan. X plus y prime is x prime times y prime, and x times y prime is x prime plus y prime. The multiplication becomes addition, addition becomes multiplication. For the XOR, I want you to memorize this because I've seen it over and over again in your So if you have A and B, the A plus X or B, it's also A prime B plus A B prime. So if I say X prime Y plus X Y prime, you say, okay, it's X plus Y, but X or Y, right?
Okay.
0, 0, 1, 1, 0, 1, 0, 1. It's 1 only when A and B are complement,
Mm-hmm. Mm-hmm.
and it's 0 otherwise.
Okay.
X NOR is just the complement of this. It's just 1, 0, 0, 1. So here's X NOR. So this is XOR. Here's X NOR. 1, 0, 0, 1.
Mm-hmm.
Does it make sense?
Yeah.
Okay. Yeah, that's the table for X NOR. Remember how we add binary numbers? 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0, and you have a carry, right?
Mm-hmm.
Do you remember?
Yes, I do.
So, suppose you have 2 bits. Let's call them A and B. This is A, this is B. This is A, this is B. But if you have 0 and 1, the sum is 1. There's no carry.
Mm-hmm.
If you have 1 and 0, the sum is 1. There's no carry. But if you have 1 and 1, the sum is 0, and you have a carry of 1.
Mm-hmm.
So we have the truth table for the output. This could be an exam question. What is the function? What is the Boolean function for the sum S and the carry? Give me the SOP for S.
You want the sum of product?
Yes,
So we have A prime B
A prime B.
and then A B prime.
That's it, right?
Mm-hmm. Yes, it's
It's it's XOR.
Mm-hmm.
So it's a XOR of the input. Let's look at the carry.
Mm-hmm.
The carry is just AB, right?
Yes.
Because you have only 1 in the last row. So C equal AB. How do we design it? Well, if you have A and then you have B, you put it in a what? XOR, right?
Mm-hmm.
S. But if you take these two and you put them in a AND gate, the
See?
carry. Yeah.
Yeah.
Does it make sense? Yeah. This is important. So A prime B plus A B prime and C equal AB. You have A and you have B. We have to feed A into a NOT. So these two go into an AND. Would you agree?
Yes.
Okay, we want A and not B. So I want
Yes, and then you connect everyone with OR.
perfect. You connect everyone with OR. So this is S. This is the sum.
Mm-hmm.
This is how you add 2 bits. So if I give you 0 and 1 here, this guy is going to give you the correct output. If I give you 1 and 1, he's going to give you the correct output. But if I give you 1 and 1, there's a carry, right?
Mm-hmm.
How do you get the carry? How do you get C? You take A times B. This guy is XOR, right?
Mm-hmm.
So
Which is,
why?
you can do it in one gate.
What's that?
You can do it in one gate.
We
and
can do
pick
it in
one.
one gate. Yeah, here's a XOR gate. And
You
so this is the sum. You have to take A and then B, but then you have to feed them in a, what is this?
and.
This is an AND gate.
Mm-hmm.
The only time you have a carry is when you do 1 plus 1, right? As soon as you add 1 and 1, boom, you have a carry.
Okay.
S means sum, C means carry. Does it make sense? 1, 0, 1, 1, 0, 1 plus 0, 1, 1, 0, 0, 1. 1 plus 1 is 0 and a carry. 1 plus 0 is 1. There's no carry. 1 plus 1 is what?
0 carry over 1.
You have to do 1 plus 1, which is 0, carry 1, plus 1, so it's going to be 1 carry 1, right?
Mm-hmm.
Plus 0, but then the carry is 0. The whole thing is 0, right?
Mm-hmm.
And there's no carry. So again, this is the new carry, and this is the sum. You have A is 0, B is 1, 0 plus 1, but then the carry from the previous calculation is 0. The whole thing is going to be 1, and there's no carry. Does it make sense? Let's say you have 1 plus 1, but then from the previous calculation, you had a carry of 0. What is this equal to?
0 carry over 1.
0 carry 1.
Mm-hmm.
0, 0, 1, 1, 0, 1, 0, 1. And then we have two outputs. We have the sum and we have the carry.
0
What?
and 0 is
0,
0,
0.
0. No, 1, 0.
1, 0.
1, 0. 0, 1.
Perfect. And what we found is S is A prime B plus AB prime, right?
Mm-hmm.
Which turns out to be A XOR B, right?
Yes.
And C is the last min terms, AB. Does it make sense?
Yeah.
Okay. Let's look at a full adder. So for the full adder, we have three inputs. We have A, we have B, and we have C. 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. If you add 0 and 0 and you have a carry of 0, what's the sum? Let's say you have 0 plus 0, but then there was a carry of 0.
0.
It's 0 and there's no carry, right?
Mm-hmm.
So this is 0 and there's no carry. What if you have 0 plus 0, but then there's a carry of 1? So let's say this guy is 1. 0 plus 0, but you have a carry of 1. What is the total?
0?
No, it's 1.
1, yeah.
But there's no carry because 1 plus 0 is 1 plus 0 is 1.
And the other one is the same, 1, 0.
This one?
Yeah.
This is 1 and this is 0.
0, 1.
This is 0, 1. Perfect.
1, 0.
1, 0.
0, 1.
0, 1.
0, 1.
0, 1.
0, 1, 1. 1.
No.
0, 1.
No,
Oh,
1, 1.
Yeah.
1, 1. And this is how he got this table. Can you give me the SOP
Yes.
for, let's start with this one. Remember, you have 1, 1, 1 here.
A prime, B prime, C.
A prime, B prime, C.
And then A prime, B, C prime. And then A, B prime, C prime. And then A, B, C.
Perfect.
We're gonna do A prime and then parenthesis, right? B prime plus B.
No, B prime C.
Oh
and
yeah,
then plus
B prime
B, C prime.
Plus, and then we're gonna have A as a common factor. And then B prime plus B,
No,
C
B prime, C prime.
Yeah.
Plus BC.
Yes. Which is, can I simplify it? Like, for example, this, 1 second.
So you have 1 here, 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 and here, right?
Yeah.
So you have
A, no, 1 second, 1 second. A prime, BC, and then A, B prime, C, and then A, B, C prime, yeah, and A, B, C.
now
A, B,
AB.
and then C prime plus C, gun.
gone. So you have only
And
AB left.
for the first function, we have C as a common factor, and then parenthesis A prime B
Mm-hmm.
plus A B prime.
Which is A XOR B, right?
Yes. Mm-hmm.
So you have A, B in a what? XOR,
Yes.
and then you have C
All with and, all of
all
them
with
with,
and then you
then
have
from A B,
yeah
A
from
B
A and B,
and then connect everything with OR.